Hi, everybody. Welcome to TIAA Now. I'm Clarence Reynolds. As we expand network virtualization, maintaining quality will be both necessary and a challenge. How will enterprise overcome? Well, we're joined by Nokia's Deepti Arora, Chief Quality Officer and Senior Vice President, John Wronka, Quality Director, and Maneesh Kumar, Head of Cloud and 5G Quality, to discuss their insights. Thank you all for being with us. Deepti, I want to start with you. Regarding 5G's exponential growth, where do you see the greatest opportunity for both the industry and suppliers?
Well, it's a very good question. 5G, of course, is world changing, and it is really representing a full quantum leap in the evolution of communications. It's going to transform the way we live, the way we work, and the way we play together. And specifically, really for our industry and our suppliers, there are three areas that really deliver the promise of 5G, or where we really see the most opportunities in 5G. These are extreme mobile broadband experience, ultra low latency, but mission critical applications, application communication, as well as the massive Internet of Things and devices connectivity from there. And again, and specifically in that space, you would have heard of connected car as a most commonly, popularly talked about use case. But then there are others. There's remote healthcare, there's remote oil and gas, so basically utilities, remote mining, connected factories, as well as smart buildings, smart cities, and you name it, the list goes on.
So that's the optimistic side. What are you concerned about?
Yes, there are certainly concerns. Besides, of course, assuring quality and the quality of experience from a use case perspective, there are a few others that I like to bring out, Clarence. Security. So if I take a look at data, if we look at things today, 5G networks are going to have so much more data compared to what Facebook and Google combined have right now. So the issues that we are facing today with the data that we believe Facebook and Google have, those will really be very minor compared to the future 5G networks and all the data that is being collected. Anytime we type something in any of our devices, anywhere, it's going to be collected there. So I think we're going to need some right regulations and right rules for the privacy of the data, for the use and abuse of the data. So the whole aspects about security is very important. A second concern that I really think about a lot also is health. So what kind of, with all the EMF radiation, what kind of health effects can have, tumors or anything like that, hormonal, what could really result as a result from there. And then the last one, much more on the safety side, both cybersecurity and physical security. So what would be those concerns?
And Maneesh, continuing on the theme of the explosion of data, what do you see as the challenges to quality of experience and services, quality of services?
Now, picking up on what Deepti started about, talking about the different use cases, whether we talk about the enhanced mobile broadband, and one of the examples which could be like virtual reality. It's one of the things which you might know is that we talk about latency quite a bit in 5G, because that's one of the critical requirements here. And if you look at the human angle of it, means for voice, 100 millisecond latency is good enough, because you need a round trip time for data to come back from the core to the edge of the network. But when it comes to a human eye, for example, and that's where virtual reality will become more important, the latency requirement is 7 milliseconds, and this is what we call technically is the vestibulocular latency requirements. So if the moment you turn your head, your eye automatically refocuses in 7 milliseconds. And if your bandwidth requirement and your latency requirement is not meeting that criteria, for example, a person who is kind of trying to be in a virtual reality environment, he might feel giddiness because it's lagging behind, the whole environment is lagging behind. So that's one of the requirements. Now, if you move to a second kind of a use case, which again Deepti touched upon, was more in terms of the ultra reliable, low latency kind of a use case, which is, say, remote healthcare. So in a remote healthcare kind of an example, if you see, we will be doing surgical operations probably remotely, and this would require a very, very high reliability. Means we cannot think of a situation where means we have an interruption in service. So the quality of service again will depend on the use case. And if you move to a machine-to-machine kind of an environment, the computation speed of each of these environments are very high. At the same time, if you look at some of the devices or the millions of devices which would be connected, they would be out in the network, billions of it. We talked about in the morning about it as well. And there, if you see, the battery life will become very, very important, in a sense that a device is plugged into the system for 10 years or 12 years or even 15 years, and you don't change the battery, you basically change the device itself, because the use case would evolve over a period of time. And then if you look at it more from an architectural perspective, the whole network, the way it has evolved, earlier it was a box architecture. We used to sell boxes, we used to kind of put the boxes together and create a solution or a network. Now we are talking about a shift, a big shift in this architecture. We are talking about a cloud-based architecture where the edge cloud becomes very, very important to address the latency requirements, for example. Then the core sits on the data center or the central cloud, and then there is the point of service. And if you look at each of these three, this brings in unique advantages as well, because this architecture also helps us solve a lot of problems from a quality perspective. If we have, say for example, the core sitting on the cloud, some of the problems which we have in terms of upgrades or the cost of ownership, which many of our vendors are having at this point of time, will be solved because we will be able to do automatic upgrades on the cloud. It will be much easier to upgrade because it will be more software centric and not hardware centric network going forward. It would be more managed through a self-defined SDN kind of an environment or a network. And then if you look at it more from the other architectural transformation we are talking about is a stateless machine architecture. This is again a unique proposition on the core side, where the session data, the data which kind of records the call, means say you are in a call right now and all of a sudden there is an interruption for some reason. In the stateless machine architecture, that interruption will not happen, and at the same time at the back end what we can do is that the virtualized network functions, we can just kill the process, start a new one, transfer the call to another one, and all that can be done automatically at the click of a button. So there are advantages of this architectural transformation. And then at a granular level, if you talk about architectural transformation, we are talking about, say, glowing microservices based architecture. Now what does that mean? That means that our architecture will be much more modular. That means also the fact that we will be able to deliver features at a much faster rate, because I know which components to touch upon, which components to fix. A faster delivery of feature means also a faster revenue realization for our operators. So that's a good positive sign as well. And then if I look at it more from going forward to a next level, digital service delivery. Means digital service delivery is again one unique proposition which we have, because if you look at Apple, it's a unique advantage they have is that you can just download any feature at any point of time as an app. Now in a network environment, that's not yet possible. But we think that with 5G and with the evolution of the cloud, this will be a big thing going forward, and this will give a unique advantage that features or functionalities which our operators are looking forward to can be delivered as quickly and as easily as possible without them bothering about too much of testing or too much of verification, where they used to take, say, years to take a new feature into their network. Now probably can be done in a month's time or 2 months' time, because we will be providing automated test cases, features in this environment. Now looking at it from an end-to-end perspective, this brings in challenges as well, because when we are opening up APIs, when we have microservices architecture, we are using a lot of open source. Now open source is something which the community is developing, and there are immense advantages of getting it easily, but also the risks of quality being compromised at it, so, and also security aspects of it. And this is something which we are very particular about, and we have to take care. And it is not just we as a vendor as Nokia, but or everybody, including our suppliers, have to take care of it. And this kind of leads to the fact that we have to look at it from an end-to-end perspective. So quality is not just about one box, one network element, one VNF, but an end-to-end experience where we have to look at it from the suppliers who are helping us, the open source community with which we are working, and even to the IoT players who would be plenty in number, so with which we will have to interop with. So The challenges are there, but at the same time, I think the evolution of the technology is also helping us fix a lot of these problems.
I think to build on what Maneesh said, the criticality of the use case is also going to determine what would be the quality performance parameters that have to be measured and that have to be managed properly.
And with the move toward greater software control, how will our view of quality need to change?
It's a very pertinent question, and actually it becomes even more relevant, even more essential that we focus about quality, because now in some cases we might be dealing with mission critical applications that are working through this 5G network, like a remote surgery or something like that, or autonomous cars, driverless cars. We have to be even more careful on the quality assurance of that use case. So if you take a look at again what we're dealing with, as Maneesh talked about, open source software, open APIs, cloud-based hybrid platforms at all layers by different players. So just a very complex landscape that one has to manage. And at Nokia, we are taking a much more of a multi-pronged approach to address these challenges. Some of the few things that I would just like to share with you are, we are looking at we're not just looking at, but we're actually doing and are part of a very strong collaborations with our customers, with our suppliers, and also with our future customers from the new verticals, be it public sector, be it enterprise, be it even the car makers, so that we can jointly design the solutions. We can jointly test with acceptance testing and sort of learn early, fail early, fail cheaply, and learn fast, which I think is going to be now the new norm. We're also working on much smaller aspects of releasing software versus big monolithic releases, and then finding out what's gone wrong with it. The third area that we are changing from a quality perspective for this new world is taking a look at our process models. So some things that are more not the stage gate waterfall, but much more scaled, agile kind of environments, and digitizing the same thing. So digitizing the process model so that we can move with much more efficiency and speed and ensure high quality in the process workflow. Another thing that we are doing is building very large scale end-to-end solution labs, to make sure that they're being tested before it goes out into the field and puts into the production environment. And finally, I'd like to also bring about that we are leaning on much more of the machine learning and artificial augmented intelligence type of modeling and predictive modeling, which can take us towards preventing and self-healing the networks and self-healing the use cases, applications, and so forth.
And John, based on your involvement with TIAA, what are you seeing that would help us with quality issues as we move toward 5G?
Well, TIAA is working on a number of programs in things that are related to smart buildings, for example, even the edge. But the ones that I'm more familiar with are really two areas. One is TL9000, which as many of the listeners here know, that it's the quality management system for the ICT industry. And one of the ways we evolve TL9000 with technology is through a product category table that allows companies to collect data by various different products to see how they are performing with respect to their competitors. So this year we're now collecting data. We've added product categories for example, the NFV orchestrator. You've heard a lot of discussion about virtualization. You also heard about VNFs, right? The virtual network functions. We've added a product category for the virtual network function manager. So hopefully by the end of this year we'll see how the industry is actually performing in those product categories. So that's one area that we're working in. And the other area that we even have to look at this year more directly is, you've heard a lot about 5G and you've heard about the pilots. So this year we need to make sure that we have 5G appropriately covered in that product category table, so that as things begin to roll out, we'll be able to collect that performance data on 5G as well.
And basically standards that relate to security and safety.
Exactly.
And latency, those kinds of things.
Latency. And one area is, since you've heard a lot about the VNFs, we've spent a lot of time this year in TIAA looking at what would be an overarching measure for VNF quality, right? And we're actually going to be looking this week at a proposal on a measurement called the virtual network function failure frequency. And it's easy to say. We know there's going to be challenges in how you will be able to collect the data, but it's brought about, I think, a lot of the challenges you've heard in this discussion. When you say a VNF failure, what does that mean? If a VNF fails, it could be more of the traditional software defect in the VNF itself, but it could also fail because the network function virtualized infrastructure just didn't provide the right compute and storage, and it could fail that way. And we've talked a little bit about orchestrating. When you need to instantiate a VNF, if that orchestrator doesn't do that within the right policy, that's another way a VNF can fail. And then you have, the things we've had to deal with forever, which is interoperability. But now you're talking about the interoperability of a VNF with another VNF, or even, some of the kind of legacy bare metal products. And the other complicating factor is this whole ecosystem where the VNF could be one supplier, the network function infrastructure could be in the operator, or the operator may actually outsource that to someone else. The MANO, which does the orchestration, could be yet another supplier. And of course you have interoperability, which has always been a challenge. So there's going to be some challenges with this, but we're working it. I think TIAA they recognize there's a lot more to do in this space, and they'll keep working that. And maybe just one point back to TL9000, you heard about the new delivery methods, right? Trying to be more agile, DevOps, continuous delivery. TL9000 just changed this year its software requirements to be a lot more generic, to basically adapt itself more to some of these new methodologies like agile. But we think we've only scratched the surface. So there's also going to be a meeting this week to discuss the roadmap, and we think somehow we need to do more in either changing the standard or providing guidance to really get into the continuous delivery, and the DevOps. So back to standards, I think they are relevant, but we have to move as quickly as the technology is moving in changing those standards.
Well, thank you all for being with us. And thank you for watching. You can see more videos on our website at tiaanow.org and our YouTube channel.